Good afternoon everyone. Today we will be discussing about the signals which are said to be generated when the data is being transmitted from one end to another end. The signals which are said to be generated, there are two types. One is said to be analog or another type is said to be digital. So what is analog signal? It's nothing but we can check out here. It refers to the information which is said to be continuous. When the data is said to be flowing from one end to another end, the data is said to be continuous, then it is said to be a analog signal which is said to be generated in this way. And whereas a digital signal, it's nothing but it refers to the information, the data, it is said to be transmitted in the format of discrete. Discrete means what? Your data, when the data is said to be flowing, okay, when the data which is said to be flowing, it will be in this format. For example, it is said to be in this format. It has a ups and downs. It stops and goes, then it is said to be a digital signal. Okay, so those are said to be not continuous. So your values, it will be in the format of ones and zeros, like that it will be your digital signal. Okay, so let's check out with the diagram. So when you consider a data which is there in the analog or digital, as I said, it will be taking the continuous values in the analog type, whereas in the discrete it is said to be taking the discrete values. Okay, so the signals which are there, analog or digital, they are said to be infinite in number when it is said to be a analog signal. Infinite, it's nothing but countless. You are not said to be counting in a proper format one by one. It is not able to count. But when it is said to be a digital signal, it is said to be limited, and the number of values, it is also said to be a limited one in the digital types. Okay, so this is the diagram which depicts and shows the flow of the data in the format of either analog or in the digital signals. The analog signals, when you are said to be having an audio signal or a video signal, it is said to be having the concept of your analog type. When it is said to be a digital signal, when your data, it is in the format of a text file or something like that, then it will be in the format of digital files. Or a picture also can be converted into a digital signal type. Okay, so these are the analog and digital signals, and even the signals can also be in the format of periodic and non-periodic. Periodic is nothing but when the waveform is in this format, okay, same format, whereas when non-periodic, it may be like doubles of it, then it is said to be non-periodic digital signal. This is the diagram. You can check out here how the periodic and non-periodic signals, it will be there in the analog type and the digital type. Analog type, you can check out, this is the type which is there, and non-periodic means it will be changing. It may be changes in the signal. Whereas digital also, you can check out, it is having the similar types of breaks in between. When it is said to be non-periodic, the flow of data, it may be in different with a certain amount of gaps. Okay, that is said to be the non-periodic. So in the periodic and non-periodic format, the format of signals, it will be periodic, it will be either it may be a simple one or it may be a composite one. A simple one, it's nothing but when your data is said to be flowing, it is said to be simple, it is said to be in the same format. Composite may be in a different way, because same type but certain changes may be there in the signal, and it is said to be having a concept called as sine wave, which is said to be generated in the waves. In this format, you will be learning about a sine wave, what is sine wave, wavelength, frequency and time domain, composite signals, that you will be learning in this session. Bandwidth, in the next session we will be discussing. A sine wave, it is in this format. Okay, when it is said to be generated, your time at each and every level, it will be countdown, it will be taking the time of all the waves, each and every wave, what is the time, what is the frequency, that it will be calculated in this way. Okay, so in the sine wave, it has various parameters. You can check out a peak amplitude, a frequency and the phase. Peak amplitude is nothing but the maximum signal strength. The maximum signal strength, this is your peak amplitude. Okay, and it will be calculated in the volts format, whereas the frequency of the signal is nothing but this is the frequency of the signal. It is said to be time. In that time only, 1 by f is your frequency. In that time, how much frequency of signals has been generated, and it is said to be calculated in hertz. Okay, and the phase is nothing but it is said to be the relative position. Okay, it may be in 0 degree, or it may be in your angle of 90 degree, or it may be in 360 degree. That is said to be your phase of the signal. Okay, so you have here, you can check in the diagram, you have the peak amplitude. Okay, here also you have a peak amplitude which is of lower one in the another one. Whereas next one, the frequency, as I said, the frequency it is said to be calculated as f is equal to 1 by t, and whereas your t is nothing but 1 by f. Both are said to be inverse of each other. Okay, then the amplitudes with different types of signalings can be checked out here. The phases are said to be different. Okay, here phase is said to be here, you have the upper phase, and here the phase in between it has changed. Okay, and afterwards the frequency of it has been changed. So there are peaks which are said to be, or phases which are said to be of different way. Okay, the period of the signal, a period and frequency can be calculated in the format of seconds in time aspect, and in frequency it is hertz, milliseconds, then kilohertz, microseconds is megahertz, nanoseconds is gigahertz, and picoseconds is your terahertz. In that way it will be calculated. The units of period and frequency, and your frequency, it will be changing in the rate of the signal with respect to time, and even it may be changing in respect to the span of time, means change in short span then high frequency. When it is change in long span has longer period of time, the span changes. Change in shorter span, then it is said to be high frequency. Long time, when it is taking too much time, your wave, then it is said to be your lower frequency. When it is time is less, then it is said to be a higher frequency one. Okay, and the signal does not change at all, then it is said to be at the 0th frequency. When it is changing continuously without any problem, then it is said to be a infinite one frequency. Okay, the phase, it's related to your relative position of time 0. Okay, here you can check out the phase. Here you have the phase which is said to be present. Okay, when it is said to be your 0th phase, here it will be in the beginning, it will be having the 0th phase. Afterwards, when it is reaching here, at the end it will be coming up and down, from down to up. So one wave, it will be 180. Then when it is reaching down, it is 360. Your degree of phase, it is said to be dependent on your degree mainly. Okay, your phase. Okay. So wavelength, next aspect is your wavelength. So in 1 second, how many waves have been generated? That is said to be your wavelength. Okay, in 1 second there may be 10 wavelengths, 20 wavelengths, or 50 wavelengths, whatever it is. How much the wavelengths are generated in 1 second, that is said to be your wavelength. So wavelength can be distinguished as it's the distance occupied by one cycle. It is called as one cycle. One cycle in 1 second, how many waveforms are said to be generated. Another word, it's nothing but its distance is a simple signal travels in one period. In one period, the number of signals which are being traveling from one end to another end. Okay, it is the counting of information which is being traveled from one end to another end in the consecutive points. Okay, one point to another point, how many waveforms are said to be generated. Okay, that is said to be one cycle, and it will be calculated in the format of lambda. It is called as lambda is equal to Vt. Okay, V is nothing but your velocity. Velocity can also be calculated as the speed of light is equal to C. It's nothing but 3 into 10 to the power of 8 microseconds per minute. Okay, and it will be calculated in meter format, your wavelength. Okay, this is the format of your time domain and frequency domain. Time domain is nothing but like in this much time, how many frequencies are being generated. That is your time slot in which the times are being generated. This is your analog format, this is your digital format. In this particular time, how many frequencies of data is being generated. Okay. So the complete sine wave, it will be represented in this spike. Okay, sine wave, it will be represented in the format of number of spikes which are said to be generated, which is said to be called as the frequency domain. Okay, frequency domain is more said to be compact. Okay, your frequency domain, it's nothing but dependent on each and every signal which is said to be generated multiple times. It may be having number of spikes. The number of spikes, same way the hertz also increases. Your hertz, frequency hertz also increases when the number of spikes are there. Okay, one may generate like this, if it comes down, comes up, comes down. So in this way your waveforms will be changing at each and every level. Okay, that is frequency domain. The frequency, single frequency sine wave is not useful in data communication. We need to send a composite signal. What is a composite signal is that you will be learning here in the next part. So mainly in a sine wave, remember, whichever sine wave, it depends upon your frequency, your amplitude and phase. The higher frequency your data flows faster. Okay, that it will be followed everywhere. So in the composite signals, it will be of two types. One is said to be your periodic, another one is non-periodic signals. Periodic is nothing but when the waveforms are in the same period. Okay, when it is not in same period, it will be in different periods. It will be generating the signals. Those are the non-periodic signals. A composite signal, it's nothing but a periodic composite signal. It's nothing but it's a type of signal. It's not typically found in data communication, but here it is said to be your changes in the signals. When your signals are there, okay, when it is reaching to the topmost signal, here some disturbance may be there. When it is reaching down, the same signals may be having the disturbances. Those are said to be your composite periodic signals. Okay. So there are the frequency domains which will be having at different levels. Your frequency of signals, it will generated in three formats. You can check out here. These are the composite signals. Okay, one is F. In the beginning, one signal will be there. This is your F. Okay, when another signal is there, which is said to be little bit higher, that is your frequency 3F. And another one signal, it is said to be a higher one. The frequency when the data is said to be flowing, it will be in the not of the same frequency level. It will be at different levels. Then it is said to be a composite signal. This is a format of signal which is said to be a composite one. Okay, and as I said, in the periodic signals, earlier whatever we have discussed, it is the part of the periodic one. When it is said to be a non-periodic one, okay, when you are said to be speaking over a microphone, it doesn't tend to have a signal which is of a constant one. It changes at the different levels, and even your phone conversation also, it changes with the signals. Your amplitude, it doesn't remain at the same level. It will be changing at different levels. So then it is said to be a non-periodic signal. Your amplitude level, it may rise to one level, it may fall. After some time, it may come here and it may fall. Like that, then it is said to be a non-periodic one. So the signals which are there either in the periodic or non-periodic, they belong to either a time domain or the frequency domain signals. Okay, so this is the part which we have learned today. So remember, what is a frequency, what is wavelength, what is phase, what is time, what is analog signal, what is digital signal, what is a non-periodic and periodic signals, that we have discussed. These are the main parts of the signals. Okay, so this is the end, and then in the next session we will be learning about the bandwidth. We will be learning about the different types of disturbances which will be there in the signals. That we will be learning in the next session. Okay, thank you.